Welcome, ladies and gentlemen, to section 1.3. So today we're going to take a look at some specifics of how we calculate different measures of center and when we use mean versus median and how it's affected when we have a distribution that's symmetric or left skewed or right skewed and all of that stuff. So I already have all of these definitions and things filled in, so you might want to pause the video for a moment to be able to copy these things down and then hear the explanation or look at the key notes. So starting off with, we have our measure of center, which is the mean. Mean is something that you've heard of since probably pre-algebra. It's your average, all right? What I want to make note of here, though, the important piece is that mean is denoted using this X with a bar above it, okay? That stands for X bar, and that means it's the mean of a sample, not the mean of the population. We'll get into that notation a little bit later, but X bar is what we use to represent the mean of a sample. You might be wondering, well, can I just use the word? Do I have to use the symbol? You're going to learn that it's going to save you a lot of time to just use the symbol, and it'll be more efficient because you need to specify that X bar, if you were to use just written word, is the mean of a sample, okay? Which might not seem like a big deal right now, but as we get more into statistics, it's going to make a difference. How that is calculated, that's nothing new for you. It's the sum of all your observed observations divided by your total sample space. So you would add them all up and then take that sum divided by the number of things. Your median is the midpoint of the distribution or the middle. So there's kind of 3 steps for a formula. We don't really have a formula here, but we have a process. So step 1 would be to arrange your values in order. So from largest to smallest or smallest to largest, really doesn't make a difference. If n is odd, your median is going to be the middle value. If n is even, though, so if the number of observations you have is even, your median is going to be the average of your 2 middle numbers. You're going to basically find the middle of your 2 middle numbers. So in the case that n is even, your median is not going to be an actual data point from your distribution. It's not going to actually be the value of the observation made. Okay, it'll be something in between your 2 middle observations. This next piece, these 3 lines here are really common for multiple choice questions on the AP exam. So it's important to have a good understanding of this. When you have a symmetric distribution, your mean and your median are going to be practically equal or exactly equal. So when you have a symmetrical distribution, your mean and your median are going to be the same value. When you have something that is left skewed, which is what I have drawn here, your mean is going to be smaller than your median. And that's because you have more values over here, which is making the middle of your distribution a much larger number, whereas your mean is then going to be a smaller number because these small values are going to pull your mean towards them because your mean is your average. Very similarly with the right skew distribution, your mean is going to be larger than your median because you have some really big values here that are going to draw your average or your mean towards it. This next piece is really important because it's very common for those multiple choice questions on the AP exam. When does it make sense to use the mean to describe the center of the data? And then the second question is, when does it make sense to use the median? When you have symmetrical data or normal data, you should always be using your mean to describe the distribution for your measure of center. If you have skewed data, left or right, or if you have some pretty large outliers, then you should be using the median. Okay, and so you'll see questions, multiple choice questions, that'll be very generic, and it'll say, we're dealing with a left skewed distribution. How does the mean compare to the median? And it could be as generic as that for those multiple choice questions, and it's going to be relying on this knowledge here. So those are your measures of center. Remember, we have our socks, right? We have our shape, we have our outliers, we have our center, and we have our spread or variability. So measure of center, it's either mean or median. For our measures of spread or variability, Now, I know there's this column of 4-hour data. We're not really going to worry about that right now, so you can just kind of put an X through it. So measures of spread. We have first quartile, third quartile, IQR, 5-number summary, and outliers. So this first part is going to be setting you up for a box plot. You likely remember this from Algebra 2, but that's what they're doing. So first quartile and third quartile, it's referring to medians. So your first quartile is going to be the median or middle of the values to the left of the original median. Third quartile is going to be the middle of the values to the right of the median. And so there's kind of this visual here where we have our minimum, we have Q1, we have our median, we have Q3, which is quartile 3, and our max. And so your median is the middle of everything. Q1 is the middle of everything to the left, and Q3 is the middle of all the values to the right. Your IQR is representing this box of your box plot, and that's calculated by doing Q3 minus Q1. It's giving you the middle 50% of your data. The AP exam is really good at giving out 5-number summaries. The thing with 5-number summaries on the AP exam, it will say something like, here's this 5-number summary. What can we conclude about this data set? Or describe the data set based on this 5-number summary. Or create a box plot using this 5-number summary. What they don't do is they just list out the numbers and they don't label them. So when you get a 5-number summary, it literally is 5 numbers connected with a comma, and that's it. It's not telling you which one is the minimum or the maximum or anything in between. So when you see it recognized as a 5-number summary, it's important to know that they always go in order of min, Q1, median, Q3, max, every time. Outliers. We talked about in a previous lesson being able to specifically calculate an outlier. So if you're going to say that we definitely have an outlier within this data set, you have to use the mathematical reasoning to support it. If not, you should be saying, we approximately have an outlier here based upon the way the distribution looks. But if you are able to specifically calculate where your outliers live within the data set, then you need to do that before claiming that there is for sure an outlier somewhere. The way that it's calculated is you take 1.5 times your IQR, you add that to Q3 and subtract it from Q1, and what that's going to do is create these barriers within your data set, and it's going to give you a low value and it's going to give you a high value, and anything outside of that low and high number is going to be considered an outlier. This should be a lot of review for you from Algebra 2. If not, we'll be going through and calculating these and an example on the next page. Very last thing is other measures of spread. There's variance and standard deviation. When we were doing statistics in Algebra 2, we talked a little bit about variance and standard deviation. It's going to be a very similar conversation, especially around variance. We mostly use standard deviation. That's the important one. There's formulas here, but really you're never going to have to do this by hand. You're never actually going to have to use these formulas. We will be using the calculator to do that for us. A big part of the AP exam is learning how to explain a data set, not necessarily doing the calculations for that data set. All right. Some notation here. S sub x is the notation for standard deviation of a sample. S subscript x. So, in a moment, I'm going to have you pause the video, and this video will end. But what I've done is in X here, I've filled in our 21 data values from our shoe data. So we had this listed here. We used this shoe data to create some stem plots in a previous example. So make sure that you get all 21 values listed in. It's not broken up by gender. We're looking at it as total shoe data. So get those filled in, and then begin going through these calculations. So it's x minus x bar. Remember, x bar is your average, so you're going to have to find that. And then you're going to square that value, and what you're doing is calculating the standard deviation by hand. So the video is going to end, and I want you to work on filling out this table using this shoe data.